Hi, I'm Hao from Shanghai Jiao Tong University, and we're very happy to present our work 360-degree panorama generation from few unregistered NFoV images published in ACM Multimedia 2023. 360 panoramas are equirectangular projected and omnidirectional maps that models a 3D scene from a fixed viewpoint. It could be used for normal FOV navigation and are also extensively utilized as environmental light sources and background textures in CG applications. However, capturing a 360-degree panorama often requires a specialized and costly equipment and also some additional human resources. Prior studies developed various learning-based generative methods to synthesize panoramas from a single narrow field of view image. But they're limited in flexible input patterns, generation quality, and also controllability. To address these issues, we propose a novel pipeline called PanelDeep, which effectively generates complete 360-degree panoramas using one or more unregistered NFoV images captured from arbitrary angles. Given NFoV inputs, we first calculate their relative rotations based on a two-stage angle prediction network, and then project them using backward equirectangular projection to obtain partial panoramas and visibility masks. Then we feed them along with the text prompts to our control-based latent diffusion model and sample iteratively in our rotating schedule to get the final generated panoramas. The generated panorama could then be used in downstream applications, such as lighting and texture background. So this is an overview of our pipeline that generates panorama from a few NFoV images. Our approach has two primary components. Firstly, a two-stage angle prediction model to handle various numbers of NFoV images. And secondly, a novel latent diffusion-based panorama generation model uses incomplete panorama and also text prompts as control signal and utilizes several geometric augmentation schemes to ensure geometric properties in the generated panoramas. Now, let's first look at our two-stage angle prediction network in detail. So the pipeline first estimates whether the input image pairs has an overlap, and then directs the image pair to the corresponding regression network. These are feature encoders, and these are regression heads for overlap cases and white baseline cases, respectively. And then let's look at our panorama generation in detail. On the left, this is an intuitive explanation of a control unit, which integrates a new control signal into an existing model block. We utilize this unit design in our latent diffusion model and makes partial FOV inputs as the control signal. The upper part and the lower part are the diffusion process and sampling process of the model, respectively. Then, to denoise 360-degree panoramas as 2D images, while also preserving their unique 3D geometric characteristics, we propose several specialized designs. Firstly, we design a customized rotating schedule, where the denoising steps are executed while the latent feature, Zi, undergoes a scheduled transformation, AR, in a step-by-step manner. Secondly, we designed a rotation equivalence loss to enforce that when the latent feature ZT and all the input image space conditions undergo a transformation AR, the predicted noise is also transformed accordingly. Additionally, we also conducted circular padding technique to mitigate the edge effects caused by 2D convolutions. We conducted experiments on both Sound 360, a hybrid indoor-outdoor dataset, and also LAVA, and primarily indoor scene dataset, while we only trained on some 360 dataset. And as a result, it can be seen that our method outperforms previous methods by a significant margin in both datasets. Here are some visual comparisons between our method and existing methods. As can be observed from the results, our method presents no edge effects, and the generated content is consistent with the input NFoV. Here's some more visual comparisons on indoor scenes. As can be observed from the results, our method presents the most realistic and high-quality generation. Our method also supports text prompt editing and are able to produce panoramas that are both diverse and controllable. As for applications, our generated panoramas could easily be served as environmental lighting or texture background in CG softwares. As could be seen from these animations rendered in Blender, with a simple text prompt, our method allows users to create high-quality, diverse, and also geometrically sound 3D imaginary background environment for CG applications. Thanks for watching.